Okay, so welcome back. Now here's another example that I did. I just want to go over with you. So we've got this problem that says differentiate the series 1 over 1 minus x squared, which is equal to this power series, which we did in the last video. Now, so it wants to use this series. We want to differentiate the series term by term to find a power series representation for this function 2 divided by the quantity 1 over x cubed on the interval from -1 to 1, which is the interval of convergence. Okay, so based on the theorem, we can do that. Okay, so when I differentiate this, the first thing I did was I set up this by taking the derivative of this with respect to x and basically substituting in for the series because this is the same as this. So now I'm taking the derivative of this series. And then I'm going to bring the derivative inside because, again, by the theorem, I can differentiate this term by term. So I can bring the derivative inside the summation, and I can write it like this. And so now, if I write out this summation, what I'm doing is I'm taking the derivative of this polynomial. And so if I do that term by term, I end up with this series, this polynomial at x. Okay, now, notice what I got here. Now, remember when I differentiated the x to the n, right? So in this case, x to the n, the derivative of x to the n, right, is what? You bring down the power and you reduce the power by 1. Okay? Now, what if I do that again? What if I take the derivative of n x to the n minus 1 with respect to x? Well, that's going to give me what? It's going to give me n times n minus 1 times x to the n minus 2. But notice I can't have negative exponents. So, and the first two terms go away. Remember what happened here? When I did this, the first term went away. So what I did was I added one to to n. I added one to n because the first term is 0. Okay, so I can get rid of that. So basically I'm going to index it by 1 and just say, okay, I still want to keep it from 0, right? I still want to start at 0, but I don't need that 0 that I got at the beginning by differentiating the constant term. So I changed it to this, right? So this I went to n plus 1 times x to the n. Well, now I've got this one. Well, now I've got n minus 2. So guess what? I'm going to add another one, right? So I'm going to add 2 in this case. So this is going to equal n plus 1 times what? N plus 2, x to the n. Because again, if I get a 0 here, right, from this one. So this 0 I don't need. So I'm just going to start it at this one. So I'm going to move it up again, another one. Okay? Now, another thing to keep in mind, well, what if we started with this? And we just took the derivative with respect to that starting there. Let's see what happens. Well, the same reasoning, right? So if I use this and I take the derivative of this nth term, what do I get? I get n plus 1 times n to the x to the n minus 1, right? Well, I'm still going to have to add 1. Well, I'm going to have to add 1 to this one and this one. So I still get the same result. N plus 2 times n plus 1 x to the n. Because why? Because this becomes 0 and I don't need that first term. Plus, if n is 0, I get a negative 1 here, which I don't want. Okay? Because remember, the power series starts at the exponent is 0. Okay? So in order to make sure that that stays the right form, I'm going to move it up. And it's okay because the first term is 0. So it's okay to do that. Okay? I'm not going to lose any information by doing that. Okay, so now, guess what? So now we can write this because guess what? If I use this, I will get all of the terms. If n is 0, I get 2 times 1 times 1, which is 2. And then if n is 1, I get 3 times 2 is 6, and I get x. If I do the next one, I get 3 times 4 is 12. If I do the next one, I get 4 times 5 is 20. If I do the next one, and so on. So I get all of them. So this is the expression. So guess what? This is going to equal the summation from n equals 0 to infinity of n plus 2 times n plus 1 x to the n. Okay. So how does this work for getting my expression? Well, in this case here, I got this okay, and so now I have to write that as a function. Okay, and so what do I get for the function? Well, that's what I'm going to get right there. Okay, and so that's my power series representation. So this is where we stop. Yeah, because it says find a power series representation for this function. And let me see here. So that's actually, hold on a second. Oh, this 2 here. So this will represent 1 over 1 minus x cubed. Okay, because again, if we do a u substitution, let's just work this out another way. So u equals 1, oh, sorry. U equals 1 minus x, right? So du equals negative dx. So if we use the chain rule here, we take the derivative, this is going to be 1 over u squared, which is then going to give us what? U to the negative 2, and so that's going to give us a negative 2 u to the negative third. So yeah, that'll do it. That'll do it. So I take that back. So this would be right. Okay, and so that's our final answer. Have a great day.